we're going to introduce you to something called the binomial distribution. And binomial distributions, or distribution, is to count x. So x is a random variable, like we just learned about in Chapter 7. That's a random variable. And x counts the number of successes in the binomial setting with parameters n and p, where n is the number of trials, the number of times I'm going to do a particular action, and p is the probability of success on each trial. So the only question is, what's the binomial setting? So we need to define that. All right, so let's define the binomial setting. The binomial setting has four conditions, okay? So number one, okay, each observation, okay? So number one, each observation falls into one of two categories, success or failure. And number two, we have a fixed number of observations. And usually the number of observations is called n. Okay? The third condition is that all observations, or we could say trials, are independent. Meaning that if someone was taking a foul shot and they got the first foul shot in and the probability of getting it in was 0.7, right, that whatever happened during the first time would have no effect on their likelihood of getting the ball in the second time. Okay? So each trial is independent from one another. And then lastly, number four, the probability on each trial is the same. So the probability doesn't change, and usually it's denoted with the letter p. So back in the previous definition, we said parameters n and p. N is the number of times you're going to perform a particular action, and p is the probability of success on each of those trials. Let's consider an example. All right, so I am not very good at shooting basketballs from the foul line. All right, so let's pretend the probability that I get a particular shot in, if I take just one shot, is 3/5. Okay? All right? And let's pretend I'm going to go to the foul line a fixed number of times. Let's say I'm just going to go 4 times. Okay. So this is a binomial setting. It's a binomial setting with parameters n and p. We denote it this way. 4, 3/5. It's binomial because there's a fixed number of trials. I'm only going to try and shoot this 4 times. On each trial, I either get the ball in or I don't. So it's success or failure. That's the first thing on the list, right? The probability of success in each trial is 3/5. And if I get one in on the first trial, the probability for the second trial doesn't change at all, okay? So it's independent. Each time I go to shoot the ball, the probability is still the same. Okay, so I can ask all kinds of questions. What I'm going to do, though, is create the probability distribution for this variable x. We usually write binomial, the n and the p, and then we put like a little squiggly line, x. So x is approximately binomial, that kind of thing. We put x, probability of x, and let's talk about what's possible in terms of values for x. Well, if I'm going to shoot this ball 4 times, it's possible I could get none of them in, right? So x equals the number of shots. I should be clear on that. X equals the number of shots I make. So I'm defining a success to be getting the ball in, all right? I could get 1 of those shots in. I can get 2 of them in, 3 of them in, or all 4. All right, so let's try and calculate some of these probabilities. So let's consider the first case, the probability that x equals 0. If x equals 0, that means I have to miss every shot. So on the first shot, I have to miss. I'll say fail, right? And then I have to fail on the second shot, the third shot, and the fourth shot. I have to fail on all 4 shots. I have to miss them all. Well, the probability of failure is 2/5 times another 2/5 times another 2/5 times another 2/5, or 2/5 to the 4th. 0.0256. Okay. Now things get a little more interesting when you try and consider some of the other values of x. So let's say I ask for the probability that I get exactly 1 out of 4 shots in. So that's what this is. This is the probability of exactly 1 success out of 4 trials. Okay, so get used to the word exactly when you see an equals here. All right, so you have to be careful with this because there's more than one case that makes this happy, right? It makes this satisfied. So I could score on the first, that could be a success, and then fail, fail, fail. Or I could fail on the first, score, or have a success, whatever you want to call it, and then fail, fail. I could do this, fail, fail, success, fail, or fail, 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 success. Okay, well, let's try and figure out the probability. The probability of this first case would be 3/5 for getting it in, and then 2/5 to the third for not getting it in. Okay? And then over here, I'd have the same thing, 3/5, right, times 2/5 to the third. It's in a different order, but when I multiply, it's not going to matter. So the question you ask yourself, how many of these do I have altogether? Well, I have 4 of them, right? So the probability that x equals 1 is equal to 4 times 3/5 times 2/5 to the third. Okay? So whatever that turns out to be, we type that in our calculators and we can get an answer. All right, so it looks like you're going to get 0.1536. So you can see we're creating a probability distribution here. All right, let's consider the next case, the probability that x equals 2. And we're going to write out all the cases here, and then at some point you're going to say there must be a faster way. And it turns out that there is. All right? But let's consider some ways that we can be happy now or get 2 successes. Right? So let's consider here. So we could have success, success, fail, fail. We could have success, fail, success, fail. We could flip these, so fail, fail, success, success. We could have fail, success, fail, success. And then I think there's another one. There's fail, success, success, fail, or success, fail, fail, success. So there are 6 ways to get exactly 2 in. All right. Now, I would think at this point, some of you are saying to yourself, wow, this is going to take a while to write out all these cases. Do I have to do this every time? The answer is no. Well, let's write down this last thing. You get 6 times. And if I'm going to get 2 of them in, so it's 3/5 squared, and then 2 of them not in is 2/5 squared. Okay, so let's type that in our calculator to get an answer, and then we'll come up with we'll show a formula that speeds this up quite a bit right now. Okay, so this is 0.3456 according to the calculator. So we'll put that in our probability distribution. And I think at this point you're probably saying, oh, there must be a faster way. And it turns out that there is. You can get the following. Here's the thing. Probability x equals k, where k is the number of successes in n trials, equals the following. It equals NCK. That's like combination, right? And probability of success to the k power times the probability of failure, which we can write 1 minus success, to the n minus k form, k power. All right? I should also note that in your textbooks, or a lot of textbooks, instead of writing n choose k like this, they'll write it this way. They'll write n with the k underneath it. That means the same thing as combination. Okay? And then what do you have here? You would have probability of success to the k and probability of failure to the n minus k. Right? Think about the formula for a minute. What's happening? P to the k is the probability of getting exactly p shots in. 1 minus p, that's when you don't get them in. That's the rest of the time, n minus k, right? And then n choose k here, the n combination k is counting how many groups have k successes in it. So let's actually check it out. I want to see if it works. So look at this problem we just did when we counted up all these cases that took a long time. Probability x equals 2, according to this new formula, would be the following. 4 choose 2, or 4 combination 2. Probability of success, which is 3/5 squared. Probability of failure, which is 2/5 squared. Well, I'm pleased so far because when I look at this piece and this piece, it matches, right? So now we just have to hope that 4 choose 2 is 6. But it is. Your calculator can do that for you if you're not sure. Let's minimize this. Let's bring it over here. Here's how you do that. You press the math menu on your calculator, and you go to probability. You see the third thing down, NCR? That's where it is. So do second quit for a minute. We want to do 4 choose 2. So here's how you do that. You type 4, math, probability, number 3, NCR, 2, hit enter, and you get the 6 that you expected. So this works. So let's go back. We're not quite done with our probability distribution yet. So let's see if we can figure out what goes here using the formula now. Well, this is the probability that x equals 3 would equal 4 choose 3. I want 3 successes, so 3/5 to the third. And I want 1 failure, so 2/5 to the first. Okay? So if you do 4 choose 3, you'll actually get 4. And then you'll have 3/5 to the third and 2/5 to the first. All right, so this is 0.3456 also. Interesting. Okay, for the last case, the probability that x equals 4, well, that's going to be 4 choose 4, 3/5 to the fourth, and then 2/5 to the 0, right? We're not going to have any failures. We're going to get them all in. What does that turn out to be? 0.1296. Okay. Now, some of these are probably rounded, but if you took the time to add these all up, you would get 1. This is a legitimate probability distribution. All right, so we're going to rewrite this. Sorry? 0.256.136.3456.3456, and then 1296. Okay. All right. So now, if we have the table, we could say, hey, what's the probability x equals any number? X equals 1. We could just read it right off the table. But once you have the table, you could do some other interesting things. You could say things like, what's the probability that x is less than or equal to 1? Right? Yeah, and that's going to equal, well, if x is less than or equal to 1, then there's really 2 possibilities. X could equal 0, or x could equal 1. You could have either one of those cases. And that just means adding the 2 things together from the table. So 0.0256 plus 0.1536, which gets you 0.1792. Okay? You could say things like this. What's the probability that x doesn't equal 3? Well, that's saying, hey, what's the probability that this person does not get exactly 3 shots in? Well, I would probably do 1 minus the probability that x equals 3. I would do it that way. You also have the option. You could have just added the other 4 cases. That's a little clunky. I'd rather do 1 minus 0.3456 and get 6544. Okay, so you get all kinds of probabilities. Now, it also turns out your calculator has some nice functionality for this that you're going to like. Your calculator can do stuff. So let's talk about that. Ready? So go to your calculator. And if you remember, when we used to want to do normal probability questions, we used to do second distributions, and we'd go to normal CDF. And normal CDF would get area under a normal curve for us. Well, if we go a little further down this menu, or just hit the up arrow, you'll see 2 things that are interesting. Binomial PDF and Binomial CDF. So those are pretty handy tools for these kinds of problems. So let me show you how you can use this. All right, so binomial PDF is for when x equals a number. That's when you use binomial PDF. So I'm going to hit enter on binomial PDF. And if we think about the problem we were working on, we asked things like, what was the probability I got exactly 2 shots in out of 4? So we hit enter on binomial PDF. We type m first. So how many times are we going to do the action? We're going to do it 4 times. You type p second. Well, the probability of success in each try was 3/5. And then the question is, how many successes do you want? So it's n, comma, p, comma, k, where k is the exact number of successes you want to have. So in this case, we wanted to get 2 in. I was just making that up here. We close the parentheses, we hit enter, and we get a very familiar number. All right, so let's just finish off. Let's just make sure we write this down and we know what we're doing here. So when you use the binomial PDF function, you always type in n, p, and k. N is the number of trials, p is the probability of success in each trial, and k is the exact number of successes I want. So we can write this. This is equal to the probability that x equals k. All right, now, if we go back to the calculator, you might have noticed that when we did second distributions, there's another one underneath there. There's something called the Binomial CDF. The question is, well, how does that work? Well, it does something slightly different. Binomial CDF. You type in the same things, n, p, and k, but it returns the probability that x is less than or equal to the number k. So we had done the example in the basketball shooting problem. We said, what was the probability that x is less than or equal to 1? So our calculator can actually do that for us. What we can do is we can type in binomial, I'm going to abbreviate a little bit here, CDF, n, which is 4, because it took 4 shots, p, the probability of success in each shot is 3/5, and 1. Now, it looks like the PDF, but it's not, because this is going to give us back that probability. Let's go type it in and see what happens. Now, just to remind ourselves, if we go back to our notes here, we had done that problem a moment ago. So let's see where I put it. Here it was. It was equal to 0.1792. You can see that right here. We had to add 2 cases ourselves. My claim is the calculator is going to do this for us. So let's see that. So binomial CDF 4, 3/5, 1, close parenthesis, enter, and there it is, 0.1792. So that's a pretty handy thing. So I could ask questions like, well, what's the probability? I can go back here and I could say, well, what's the probability in the basketball problem that I got 3 or less shots in? Well, according to what I just told you, that's the binomial CDF of 4, 3/5, 3. And that's really going to do is in that table that I had, it's going to add all 4 of those cases for me, which is not something I want to do by hand. So let's see what happens when we do that. We should expect a pretty big probability. Second distributions, binomial, there it is, CDF, oh, that's PDF, we want CDF, and we type 4, 3/5, 3, enter, and 0.8704. So that's a pretty handy little tool. Now, there are some limitations, because what if I asked this question? What if I said, well, what's the probability that x is greater than 2? In other words, that I get more than 2 shots out of 4 in. Well, the CDF only does less than or equal to. So for a lot of these kinds of problems, when it has a greater than in it, you're going to have to rewrite them. So let's think about the opposite event of x is greater than 2. The event that's opposite of x greater than 2 is x is less than or equal to 2. So if I do 1 minus that probability, I'll get this probability that I want. So that's my advice. Anytime you see probability x is greater than 2 or greater than some number, you're going to do 1 minus the probability x is less than or equal to that number. Now this I can do in the calculator, because that's going to be 1 minus the binomial CDF of 4, 3/5, 2. So we can type that in. Let's go do that and just practice real quick. So 1 minus second distributions. We go up to that binomial And CDF, there it is. So we have 4, 3/5, 2. Enter. Let's see. Oh, let's make sure I did that right. Hold on a minute. Second enter. I did 3/55. Hold on a second. Let's delete that. There we go. And we get the answer of 0.4752. That's what you get, 0.4752. All righty. Now, one more tricky little question to worry about. Because what if I had asked for the probability that x is greater than or equal to 2? So that's like saying, what's the probability I got at least 2 shots in? All right. Well, I want to write this in the opposite event, but a problem occurs as soon as I do that. Because the event that's opposite of x is greater than or equal to 2 is x is less than 2. Well, there's a problem. The calculator does not do the probability that x is less than 2. It won't do this. It only does less than or equal to. So I have to have this realization that the probability that x is less than 2 is the same thing as the probability that x is less than or equal to 1. Okay? Once you have that realization, you're fine, because now you can go and do 1 minus the binomial CDF of 4, 3/5, 1. But this is the key realization here. You have to have that realization. So again, anytime it's greater than, we're going to change it to the opposite event like we did over here on the right. And then you have to have this additional problem, because if it's strictly a less than, we're going to have the realization that it's less than or equal to 1 minus, or 1 less than the number we're interested in. All right, hope I said that clearly. Let's type this in and see what we get. All right, so I could just do second enter, and I'll change that 2 to a 1. And we get a slightly bigger probability, the 0.8208. We should have expected that because we're including the case where I got 2 shots in. All right. Thanks for watching.